Okay, good afternoon to all. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Right. Yesterday we discussed about the simplex method under LPP, linear programming problem. We discussed how to solve a business problem converting into a linear equations as LPP problems. Question 8, that is formulation part, we discussed at the beginning. After that, we discussed how to solve it by graphical method. Then we discussed about the simplex method also, as how to solve any business problem through simplex method. And if the variables are the two or more variables are there in the decision criteria, then we'll be using a simplex method. But it is highly impossible to do the sum. Anybody practiced about the simplex method yesterday's discussion? Anyone among you? Have you tried?
Yes, sir.
Yes.
I have tried.
Do you got
Yes,
some?
sir. The same problem what you have told yesterday, I have tried it. I understood.
Good, very good, nice. The point is, if you can able to do it, it is very good. We are going to discuss the same thing once again because some may not be getting it immediately whenever they learn. Yes, Venkatesh
Yes, sir.
Garu.
Yes, sir. Yes, sir. Please repeat. Sir.
That's what I want to explain. It not the same question. Actually, the another question on Excel sheet, right? So that you can little bit more I can understand. I can do
Okay, sir.
right. Good. I'm sharing the screen. Okay. This is the question actually where we can do with the graphical method as well as with the simplex method also. Right. The question, find the optimal solution for the following LP by using graphical method is given here as an objective function. This will discuss in the simplex way. Graphical also we can do it, and simplex way also we can do it. Where the question objective function given to us, maximize z equals to 10x1 plus 40x2, subject to the conditions x1 plus 2x2 less than or equals to 100, x1 plus 5x2 less than or equals to 150, where the x1 and x2 greater than or equals to 0. Right? This question first we need to convert into a simplex format. To convert into a simplex format, first we should know the constraints. These are the two constraints which we have, and these constraints is a less than or equals to equations. So when it is less than or equals to equations, what I said, we need to add the slack
S1.
variables, right? Slack variables, we'll call it as S1, S2, but the slack variables we'll need to call it as. So x1 plus 2x2 plus 1s1, right? 1s1 plus 0s2. Why 0s2 I'm calling? Because we need to add one more slack variable to another equation. So for both the things combinedly, we can show in this way, is equals to 100. This is the first equation. Then second equation, x1 plus 5x2 plus 0s1 plus 1s2 is equals to 150. These are the two conditions or the constants which we are converted into a simplex format. When we convert these two into simplex format, we are adding a slack variables to each equation. So S1 and S2 are the two slack variables which we need to add to the objective function. The objective function given to us here is maximize z equals to, right? So z equals to 10 x1 plus 40 x2 plus 0 s1 plus 0 s2 is the objective function. So converting normal LPP question into a simplex format. Now this we need to keep it in the table. The total thing we need to keep it in the table means what are the headings we need to keep. The first CB stands for what I said. CB stands for yes,
Coefficient of chosen basic variable.
right. Coefficient of basic variables, right? Good. Then basic variables, then solution variable. Then the variables are x1, x2, s1, s2, right? With the minimum ratio. This is actually the table which we require. Above the solution variable, we can write down as Cj. Cj stands for coefficient of objective function. So first we'll write in the table is coefficient of objective functions, which are converted into a simplex format here on the top. Z equals to 10x1 plus 40x2 plus 0s1, 0s2. So if you keep all these things, so objective function coefficients of x1 coefficient of objective function is 10, x2 coefficient is 40, s1 is 0, s2 is also 0. These are the values of objective function. Then in the first table 1, this is the table 1 what we are preparing. In the first iteration 1 or the basic iteration, we need to consider the basic variables as slack variables s1, s2. So every time we need to consider these things under the same S1, S2 are the basic variables we need to consider, and the basic variable coefficients of the objective function we need to take as 0 and 0 only. So both the things 0 in the first table, and the equations we need to consider. See once, I'll zoom it once. If you can able to see, it is good. So can you see now clearly? So S1, S2 are the basic variable and their coefficients are zeros in the first table, and the equations we need to consider. So in the equations, that is constraint 1, constraint 2, we need to take it in the form of a table. So to convert or take the into the table, we need to take all the coefficients. The first equation we have is x1 to x2 plus 1s1 0s2 is equals to 100. So 1x1 2x2 1s1 0s2 is equals to, solution variable is 100. Any doubt regarding this? Next.
No, sir.
Sure, thank you. Then second equation 1x1 5x2 0s1 1s2 is equals to 150. This is actually the simplex table. We are taking all the coefficient of the constraints and the objective function. After taking into consideration all these things, first what I said to do, we need to find out Zj. Zj is nothing but multiplication of these coefficients with the total row values. So 0 into 100 plus 0 into 150 is the value what we should take here as 0 only in the first table, because all the values, if you multiply with the 0, you'll be getting 0 only, right? After that, what we need to do, Cj minus Zj. So Cj coefficients are here, Zj coefficients are here. So 10 minus 0, we'll be getting the values here. We can write it here. 10 minus 0 is 10. Then 40 minus 0 is 40. 0 minus 0, 0 minus 0. Among all these values, the highest positive value we need to consider.
Sir, what is ZJ? Multiplication between?
This coefficient of basic variables into the variables of all this solution with the all x1, x2, s1, s2.
There are two equations. Which equation?
Both the equations. 0 into 100 plus 0
Yes,
into
addition.
150. Yeah.
Okay.
Both should be added and shown as a Zj, because Zj is nothing but x1 plus x2 combinedly. Right. So when we come to the next equations, when we will be getting a coefficients, you can understand again further. Right. That Zj first table obviously 0, because if you multiply and add all zeros only, you'll get. So in the first table, Cj minus Zj is nothing but whatever Cj's are there, the same values will be. Among all these values, whichever is highest positive value in this is considered as a key column. So highest positive value is this one, right? 40 is the highest, 10, 40, 0, 0. So among this, the highest positive is 40. So this column is considered as key column. Any doubt?
No, sir.
So Cj minus Zj, whatever we got, in that highest positive value column is considered as a key column. And these key column coefficients we have to take, and these two, because two equations, their solution values are divided with this key column elements. So 100 divided by 2, 150 divided by 5. 100 divided by 2. If you do it, how much you will be getting? 50, right? The second 150 divided by 5. Key column elements only. So 150 divided by 5 is nothing but 30. So among these two, minimum ratio is considered. So which one is the minimum? 30 is the minimum. One is 50, another one 30. So 30 is the minimum. This row is considered as a key row, right? So column wise maximum positive, row wise minimum. And the intersecting point is considered as key element. This is considered as key element. So we have taken into this as this one, as 5 is the key element. What we need to do, we got a key element or pivot element. With that only we can find out the row values of this row. In which row we got the key element? Second row. So what we need to do here, we need to find out the new row values of the second one. So R2, row 2 is equals to R2 old values divided by the key element. What we got is 5. If you divide it by 5, all the elements, you'll be getting the new row values. This is your new row values. So row 2 is the new row because key element we got in the second row, right? And to find out the new values, divided by 5 every element. So 150 divided by 5, you're getting 30. 1 divided by 5, right? 5 divided by 5 is 1. 0 by 5 is nothing but 0 only. 1 divided by 5. Is this clear?
Yes, sir.
What we did in the Cj minus Zj, the maximum positive value column is a key column. And with this key elements, if you divide with the solution variables, divide the solution variable with these key columns, you are getting a ratio that among those two values, the minimum ratio is considered as a key row and the intersecting value is considered as a key element. So this key element only will take and divide it with the total row, you will be getting the new row values. Second row values we got. So how to find out the first row values? That is row 1 is the other row, we can say. So to find out row 1 is calculated. Row 1 is equals to old values of row 1 minus key element of the first row. Key element of the first row means not 5. First row key element becomes 2. So 2 into the new row values. New row values. That is the values what we got here. So first what we'll do is we'll take the first row old values and we'll see how to calculate. You can see here old values of row 1 is 100. First solution value onwards, 100 minus 2 into new row value. What we got in the solution value is 30. Are you getting my point? 100 minus key element of first row into the new values is 30. New row value is 30. Similarly, the second x1 coefficient 1 minus 2 into what we got, this 1 by 5. Similarly, the second x2 coefficient, 2 minus 2 into the neuro value is 1. Anyone having any doubt, you can raise your doubt. Next, S1 coefficient 1 minus 2 into the neuro value of S1 is 0. Similarly, the last S2 coefficient is 0 minus 2 into the new element value is 1 by 5. This is the calculation for the other row other than the key element. If you calculate what are the values you'll be getting for the first row, 2 into 30 is 60, 100 minus 60. If you do, you are getting us 40. Here 1 minus 2 by 5. If you calculate 2 by 5, that is 2 divided by 5.
3 by
Right. 3 by 5.
0.
3 by 5 here we'll be getting, the next is 2 minus 2 is 0, 1 minus 0 is 1, 0 minus 2 by 5 is minus 2 by 5. These are the new values for the other row. With this, what we need to do, we need to prepare a new table. Right. The same. So the new values for this what to do. First, we got in which row as a key element. The second row, we got a key element. So this S2 is replaced with X2. So we need to consider here in the place of second row, in the place of S2, we need to consider X2, and the coefficient of X2 is considered as 40. Any doubt? We need to consider this. If you make it in this way, it is easy to understand. Yeah. So S2 is replaced with X2 and the coefficient of X2 is 40. Next, all the new values of this row. What we got, the new value is 30, 1 by 5, 1, 0 and 1 by 5. That we need to consider. 30, 1 by 5, 0, 1, 0 minus 1 by 5. These are the values for the second row. Where first row we didn't got the key element, so as it is S1 and the coefficient for this is 0 only. And the new values what we got here, we calculated already 43 by 5, 1, 0, 1 minus 1 by 2 by 5. That we need to consider in the place of first row. 43 by 5. Here it is 0. Here it is 1 and minus 2 by 5. So now we got the values. So S1, S2, S1, X2, and these values. Now what we need to do? The same procedure. First we need to find out Zj. Zj, how to find out? I said this first row is multiplied with the coefficient of basic variable is 0. If you multiply with this 0, all the values will be 0 only. Only the changes we'll be getting is this second row. 40 into 30. 40 into 1 by 5. 40 into 1. 40 into 0. 40 into 1 by 5. That is the value what we are getting in the second table. Because first row will be 0. 0 into anything is 0. 0 plus whatever we multiplied with the second thing, that only will be getting. 40 into 30 is
1200.
1200.
8.
Right.
40.
40 into 1 by 5 is 8. 40 is getting,
0.
and this is 0.
8.
8.
So round out.
Yeah,
Why CB in second row is 40?
because we got the key element in the second row. So S2 is replaced with X2.
Okay.
Key element we got here. So in the key row element only, it will be replaced. So in the place of S2, X2 is replaced and the X2 coefficient is 40. X2 coefficient is 40.
Okay.
Right.
Okay.
One second. Hello. Yeah. Is that clear? Having any doubt?
Yes, sir. Clear.
Now we got Zj. The next Cj minus Zj. We do Cj minus Zj again. 10 minus 8. We got 8 here. So value will be getting here is
2.
2. Here it is 2. Here it is 40 minus 40 is 0. 0 minus 0 is 0. Here 0 minus 8 is minus 8. So among this total row, that is Cj minus Zj, maximum positive value we need. If you got all zeros or negative, then we can say we reached our optimal solution. Till that we need to go to. So here we have one positive value, which is the highest among all other things. So this column is considered as key column. Is that clear?
Yes, sir.
So maximum positive value is 2. So we got a key column is this. So with this key elements only, we need to divide it by solution variables. We have a solution here, variables are here, 40 and 30. If you divide 40 divided by 3 by 5, 40 divided by 3 by 5, how much you will be getting?
24.
How do you get it?
Multiplication is 24. 200 by 3.
Yes.
66.
So 200 by 3 is 66.66. So 67 you can consider in case if you want to make it as round figure. Okay. Whereas here 30 divided by 1 by 5 is how much?
150.
150. So the least among these two is the minimum is 66.66, right? This row is considered as key row. Are you getting my point? The key row is this one, and the key element is 3 by 5. Because intersecting point only is considered as this one is the old row, this is the new key column and the key row, and the key element is this one, right? Now what to do? Again, we need to go through the same procedure, finding out the new values of this total row by dividing it with 3 by 5. If you divide it by 3 by 5, you'll be getting the values, right? The new row values. New row values, what may be the new row values? 40 divided by 3 by 5, we got 67, 66.66. 3 by 5 divided by 3 by 5 is 1, right? 0 divided by 3 by 5 is 0. 1 divided by 3 by 5 is 5 by 3. Five by 3, and this is minus 2 by 5 divided by 3 by 5 will be how much?
Minus 2 by 3.
Minus 2 by 3. Very good. Your maths related, then you can do it easy. These are the new values of the key row element. That is, which row actually it is? Row 1. Row 1 equals to row 1.
3 by 5.
Row 1 divided by 3 by 5. We are getting all these values, right? Whereas the other row now becomes row 2. So row 2 is equals to old values of row 2 minus key element of row 2 is 1 by 5. 1 divided by 5 into the new row values. Is this clear? The procedure is same for every table, but be careful while doing the calculation part. If you do any silly mistake, you won't get your optimal solution. You will be circulating table after the table only you're going to prepare. You won't reach your optimal solution. So second row, we are finding out the new values. So old values are these values, 30, 1 by 5 and all these, right? So first 30 is the old value minus 1 by 5 into the new row values. What we got? 66.66. So 67. Doubt? Any doubt?
No, no.
One minus 1 by 5 is the key element into the new value 0. These are the values what we are considering the new row values. Old values are these values. So next value is 0. So 0 minus 1 by 5 into 5 by 3. The last one is 1 by 5 is the old minus 1 by 5 is the key element into the new row value is minus 2 by 3. If you find out these values, what may be the new value? So what you'll get the new value for this? 66 by 5, 15, 150 minus 66 divided by 5. 150 minus 63 by 5.
67.
Mm-hmm.
150 minus 67.
Yeah. 150 minus 67
Divided by 5.
divided by 5.
16.6.
16.6. 66 or 16.7. Similar, 1 by 5 minus 1 by 5 is 0. Right? 1
Yes.
minus 0 is nothing but 1. Here 0 minus 1 by 5 into 5 by 3. 5 get cancelled, minus 1 by 3. Right? And here minus into minus becomes plus. 2 by 15. So 3 minus 2 minus 1 by 5, is it?
Plus it will become plus.
Sorry. Plus no. 3 plus 2, 5 by 5. That
5 by 15.
5 by
15.
that means 1 by 3 only.
1 by 3, 0.33.
1 by 3. By 3. This is minus 1 by 3. These are the new values of the second row. Which row we got the key element? The first row. So when we got the key element of the first row, what we need to do? S1 is replaced with X1. Right? S1 is replaced with X1 and the coefficient we need to consider as 10. Okay. So new table I'm writing beside this one only so that it is easy to understand. CB, BB, SC, X1. S1, S2. And about this is CJ. CJ value is the same as 10, 40. So in the Excel, there are so many points to be taken care of. To understand. Okay. PB values 10, 40, 0, 0, where the new values, the basic variable will change. So in the place of S1, we need to consider X1, and the coefficient becomes 10. And the next one is X2, already we have, we can't change that one, 40. So first we'll write the new values of new row only. That is the row where we got a key element. So here the 66.66, that is 67, we got 1, then 0, then 5 by 3 minus 2 by 3. One second. Okay. So that is the new row values, and the other row values which we got here as second row values. What values we got here? 16.6, that is 16.7. We considered 0, 1, minus 1 by 3, and here it is plus 1 by 3. Right? These are the values which we got. Any doubt? Yes, any doubt?
No doubt, sir.
Now what to do? Again the same procedure as I
Yes.
told you, ZJ. Now ZJ, how to calculate?
10
This,
into 67 plus 40 into 16.6.
very good. So here I'll write it clearly, 10 into 67 plus 40 into 16.7. This is your new value of ZJ.
16.6.
So how much you are getting? 670 plus how much you will be getting?
But it is 16.6 only.
16.7 or 6. Okay. 16.6 exactly we got, no?
Yes.
One second.
Thirteen 34.
So how much you are getting?
1334.
1334. So 1334 is the value for this. Hello. Hello. Yeah. Am I audible?
Yes, sir.
Yes, sir.
Right. Sorry. There is an urgent call, so that I need. So here 10 into 1 plus 40 into 0. You'll be getting
10,
ZJS 10 only.
10, 40,
Here the next is 40.
40, 3.33,
If you multiply 10 into 5 by 3 minus 40 into 1 by 3.
10 by 3.
So 10 by 3.
3.33,
So we'll write 10 by 3 so that people may not be confused. Next is 10 into 2 by 3, that is 20 by
20 by 3.
3 by 3. So again
20 by 3.
20 by
20
3.
by 3.
Why I want to write it as it is? Because if you make it somewhat decimal, somewhat fraction, somewhat other way, means it is not possible to understand by the people. So everything is in the fraction. I'm making it. Now the next, what we need to do,
Minus JJ.
right?
CJ minus
CJ
ZJ,
minus ZJ.
ZJ, 0, 0,
So CJ values here 10, 10 minus 10 is 0.
0,
Second one is also
0,
0. Then here 0 minus 10 by 3 is minus 10
minus
by
10 by
3.
3,
Here we are having minus 20 by 3.
20 by 3.
End of the problem.
So we reached the optimal solution by seeing these values because all are in the 0 or less than 0. When it comes to 0 or less than 0, we can say we reached our objective so optimal solution. So what is an optimal solution? The
1330.
x1 is 66.67 or x value is x1 value is considered as 66.6,
7.
right? X2 value can be considered as 16.6, then z value is considered as 1334. This is our solution. Any doubt? I think you may not be getting any doubt. Once again, you try to solve it, then you can be very clear to solve any type of question.
Sir, instead of writing in decimals, can we directly write in the fraction format and give the solution also, sir, at the last?
Yeah, you can make it that.
Okay.
If you multiply with that one also, you'll be getting it, the solution.
Yes, sir. That's what I was getting because again, doing it in a decimal, sometime we'll be doing some mistakes. So directly, if we write in
Fraction
the
you can do.
fraction format, can we do it?
Yes, you can.
Mm.
You can do it. So Right. So can you able to do this sum? There are the three equations here. Even if the equations are three, the procedure is same. What we need to do, x1 plus 4x2 plus 1s1 plus 0s2 plus 0s3 is equals to 24. Can you able to understand what I want to say?
Yes, sir.
So if there are the three equations, we need to add three slack variable, s1 for first, s2 for second, and s3 for three. So shall we do fastly this sum? We'll go with the table. Directly CB, CB, SV, 1, 2. The table may be big, but the point is same. Coefficient of objective function 2, 5, 0, 0, 0. Simultaneously do with me, no problem. Basic variables.
Sir, only first one, only one S1 we have to take, sir. Other all other concepts 0 S1, 0 S2, 0 S3, like that.
S1 is 1s1 for the first equation. Because
Okay,
it is
after
first
that, how many
equation, we
equations?
added the slack variable for the first equation. Second equation, we are adding the s2 as a slack variable, so 1s2. For third equation, 1s3, where other slacks will be zero coefficient for that equation. So we are adding the slack variables for each equation, one slack variable.
After that only all are 0 is 2, 0
Zero,
is 3, like that.
So why we are writing? Because to write the values clearly. So in that
Okay.
equation, S2, S3 won't be there. So their values are zeros.
Yes, sir.
Is this clear what I'm doing it?
Yes, sir.
Row 1, we got a key element. So we'll be finding out the row 1 values with key element, then the other value. So 24 by 4, 6, 1 by 4, then 4 by 4, 1 by 4.
One doubt.
Yeah.
In the minimum ratio column, in the second row,
Yeah.
I think it's 21.
21 by
1.
1. Okay. Right. So if I divide it by 0, this is 0, 0 by anything. These are the new values of the first row. Then second row, row 2 is getting by R2 old values minus key element of row 2 is 1 only here. So 1 into the new row value. Calculate in this way, 21 minus 1 into 6. So 21 minus 6 is 50. Then 3 minus 1 into 1 by 4. Minus 3 12, 11 by 4. One into one minus zero. Minus 1 by 4. Is 1. Row 3 is also in the same way. Row 3 minus the key element is 1 multiplied with the new row. So 9 minus 1 into 6. So 9 minus 6 is 3. Similarly, 1 minus 1 into 1 by 4. Minus 1 by 4. 1 minus 1 by 4 is nothing but 3. 4 minus 1 is 3 by 4. Am I correct or wrong? Once
In the third row, neuro means which neuro, sir? Second neuro?
first new row only. The new row is nothing but the key element row only, which we calculate.
Okay.
That is new row. First row, wherever we got the key element, that is only the new row for all other values, all other rows. You have 1 minus 1 into 1. 0. So the 0 minus 1 into 1 by 4 minus 0 minus into 0. 0. Is this correct or wrong? Once check.
Correct, sir.
Yes, sir. Correct.
Go with the table only. The first row will be replaced. The S1. This S1 is replaced with the X2. The second row we got. So S1 is replaced with X2 and the coefficient of X2 is considered as 5. So X2 coefficient where all other things are same. S2 here, S3 here. There is the coefficient for these is zeros only. And the new values we need to consider by means of these only. What we got? 6, 1 by 4, 1, 1 by 4, 0, 10, 15, 7 by 4, 0, minus 1 by 4, 30, 3 by 4, 0, minus 1 by 4. Now again the same. What we'll do first, Zj will calculate. Zj is nothing but only the first row values will be multiplied with the 5. The second and third row we don't have the coefficient zeros, only the coefficients. If you multiply it will be the same. So this is 5 into 6, 30. 5 into 1 by 4 is 5 by 4. 5 into 1, 5 into 1 by 4 is 5 by 4. 5 into 0, 5 into 0. Okay, Cj minus Zj. So Cj minus Zj, 2 minus 5 by 4. 2 minus 5 by 4 is nothing but
3 by 4.
3 by 4. 5 minus 5, 0, 0, 0. So maximum positive value is this one. So 3 by 4 is the positive value. So this column is considered as key column. We divide these elements with the solution values. We'll be getting it. So 6 divided by 1 by 4 is 24. 15 divided by 11 by 4 means 4 by 11 it comes. In 4, 60, 60 by 11. 5.1. How much will be getting? Or 60 by 11. 3 divided by 3 by 4 is nothing but 4 by 6. Or 2 by 3.
3 divided by 3 by 4 is 4.
4. So the least value is 4 only. Is that correct?
Yes, sir.
The element is 3 by 4. If you calculate the new value or new row, the new row is third row. Row 3 is row 3 divided by key element is 3 by 4. So 3 divided by 3 by 4, 4 by 3, that is 4, right? is 1, this is 0, one by 4 divided by 3 by 4 means minus 1 by 3. Four by 3. Is this correct?
Yes.
Then the second row, sorry, the other rows is nothing but the first and second row. So we'll go for the first row. R1 is equals to R1 old values minus the key element is 1 by into the new row values. So the new row values are these values, right? So if you take old value, first row is 6, 6 minus 1 by 4 into 4. So 1 by 4 into 4 is nothing but 1 only. So 6 minus 1 is nothing but 5. So old value here is 1 by 4 minus 1 by 4 into 1. So 1 by 4 minus 1 by 4 is 0. Old value is 1 minus 1 by 4 into 0. So 1 by 4 into 0 is 0. So 1 minus 0 is 1. Right? The next is old value is 1 by 4 minus 1 by 4 into the new value is minus 1 by 3. Minus into minus becomes plus 3. 3 plus 1, 4. 4 by 12. 4 by 12 is nothing but 1 by 3 plus 1 by 3. Is that right or wrong? Once check properly. I'm doing directly.
Correct only, sir.
Right. Thank you. This is minus 1 by 3. Sorry, minus. Yeah. Row 2 is equals to row 2 minus the key element is 11 by 4 into new row value. We go with that one. 15 is the old value minus 11 by 4 into 4. So 4 gets cancelled. 15 minus 11 is nothing but 4. 11 by 4, 11 by 4 into 1 is 0. 0. 7 by 4 into 0 is 0. All values minus 1 by minus 1 by 4 plus 11 by 2 1 by 4. So plus 11 minus 3. 11 minus 3 is 7. Sorry, 8. 8 by 4. 8 by 12. 2 by 3. Once you check, is there any mistake happened, then we go further. Any small difference you can tell me, will make it. But if any small mistake happens, it's not possible to get our solution. So which row we got key element, the third row. So S3 is replaced with X1, right? X3 is replaced with X1. Sorry, X1. S3 is replaced with X1 and the coefficient is 2. Where in the first row X2 as it is, the coefficient is 5 only. Then second row, there is no change. So S2, the coefficient is 0 only. Only the changes happens here. So third row, we got the new values. So first we'll write while taking these values also. If you have correct, then it is 2. Otherwise, you'll get confused. All are correct?
Yes, sir. Same I
Okay.
have.
So the third row, we got the new row values. So new row values, what we got? 4, right? 1, then 0, then minus 1 by 3, 0, and 4 by 3. That is the third row. And the next is first row. First row values, we got 5, 0, 1, 1 by 3. Here it is 0, minus 1 by 3. Then the second row is 4, 0, 1, 1 by 3, 0. Sorry. 0 we got, 0 we got,
0, 0, 0, 0, 2 by 3.
2 by 3, 1,
So,
minus
11
11 by 3. Is the correct one, right? Now Zj, we calculate Zj, 5 into 5, 25, plus 0 into 4, 0, 2 into 4, 8. 25 plus 8 is 33, right? And 0 into 5, 5 into 0, 0 into 0, 2 into 1 is 2. Here 5 into 1, 5, 0 into 0, 2 into 0, so 5. This is 5 by 3 minus 2 by 3. 5 minus 2 is 3, 3 by 3 is nothing but 1. 5 into 0, 0 into 1, 2 into 0, this is 0. This is 5 by 3 minus 5 by 3 plus
1. 8 by 3 minus 5 by 3.
8 by 3 minus 5 by
5 by
3.
3.
Right. 3 by 3 is nothing but again 1. Cj minus Zj. If you do carefully, you'll be getting the correct values. 2 minus 2, 5 minus 5, 0 minus 1, 0, 0 minus 1. So here we can say we reached our optimal solution. So what is the optimal solution? This is your optimal solution.
What about x3, sir? x3 is not there. x3.
X3, we don't have X3. We have two variables
Oh,
only, no?
okay, right.
So our solution is here. X1 is equals to 4, right? X2 is equals to 5. Z is equals to 33. We can go through the graphical method also because we took only the two variable equations only with 3 equations. Here this question is consists of 3 equations. So this is more than enough to solve any problem in your examination also. 3 equations is maximum you'll be getting, not more than that.
For minimization, is processed different.
A slight different and mostly they won't give. That is an engineering related.
Okay.
So MBAs you won't be getting it. We can do, but point is waste of time.
Okay.
Because they
That
have
is,
given an example problem, sir, of minimization, in which they have considered m as a value and they are solving.
yeah.
So if you
M
can tell us, it
is
would be good.
considered when there is a greater than or equals to equations
Okay.
that we discussed. We need
Yes,
to
sir.
subtract the surplus variable and we need to add the artificial variable.
If m is
And
there, then how would be considering the minimum value or maximum value, sir?
number of m's, 4 m's, 5 m's.
Okay. That means the problem solving method would be completely the same. Only extra is the m value.
M
And
values.
based on the m, we'll be choosing whether which is the minimum value or which is the maximum value for the z value.
Z, right.
Okay.
So is this clear to you what we discussed till now?
Yes, sir.
So module, that is block 2, we have LPP this. Under the LPP, one more point actually I want to tell you. See some values where it is out of boundaries. The boundary is not exactly what we have to find out a solution. If the boundary is out of control, it's out of the limits, then it is unbounded solutions, we'll call it as. Unbounded solutions, we go through your PDF also. So that I'll tell you in the class. Here it is not finding out. I kept it actually in the PPT, but it is not finding out. Not recently. Anyhow, we'll discuss that one. So that means in the linear programming problem, if there is a situation like uh, the boundaries to be framed to find out exactly the feasible area. To find out the feasible area, the equations are not satisfying at the point where we can't find out the feasible area. So then at that point of time, we can say it is an unbounded solution. Unbound solution means there is no solution for that. There is no boundaries at all to find out the feasibility, which satisfies all the conditions, whatever the conditions are there. So at that moment, we can say directly it is unbounded solution. Is that clear? So there is no boundaries to fix. Like in the graphical method, we kept a feasible area, either it may be a maximization case or minimization case. In that area, we can't find out because of the equations are beyond the level. Beyond the levels. Some are less than equations, some are greater than equations, where both the conditions are not satisfying at a particular region. Then at that time, we can say it is an unbounded solutions. So that is there in the module, that is block 2, as exceptional cases or primal or dual cases. So linear programming may consist of the problems related to exceptional cases where there is no boundary to find out the solution. These are all exceptional cases, we can say, where we can't find out the solution for that type of problems. Apart from that, we have in the second block is about transportation problems. Transportation problems. So we'll discuss that now. We'll discuss a theory part, then numerical part. We'll do it in the next class. Right? Are you getting my point?
Sir, is the prime and dual problems are also the same type of problems, sir, like unboundedness only?
Not an unbounded, actually. There is a primal situation where we can consider only some equations, not all the equations given in the question.
Sir, if the time permits, can you please give an example for the primal and dual at the last, maybe possible, if
Yeah.
possible?
In the next class, I told you, I kept it in the PPT, but I'm not finding out to explain it
Okay.
clearly. So in the
Okay.
next class, I'll be giving you that description.
Okay, sir.
You can understand.
Okay.
Whereas in the block 2 only, we have transportation as well as assignment. As I told you, this is also one of the OR technique where we can find out the solution, best solution to transport the goods from different places to the different destinations. So what is the problem here? Most of the times this is used by logistics companies or transportation companies, where the different locations they'll be having to send the goods from one place to another place. So at the time they try to reduce the cost as much as possible so that they'll be getting a maximum profit. Okay, so the question here, most of the situations is like minimizing the cost, means cost per unit values only will be given. Means what? Like from Hyderabad to Delhi, they want to transport some goods. How much cost is incurred to transport the goods? Similarly, from Hyderabad to Bangalore, how much cost incurs to transport the goods? So all the questionnaires will be given in cost per unit. Means most of the time it is treated as a cost matrix because it will be given in the form of a matrices only. So matrices, the rows and the columns will be there. So in the rows and
Sir.
the columns, rows and the column wise, they'll be giving you the problem of the business. Yes. Yes. Having any doubt?
No, sir.
Okay. So the overview of this one as a transportation formalized by the French mathematician as Gaspar Monge in 1781. And in 1920s, Tolstoy was one of the first to study the transportation problem mathematically. And in 1930, he published a paper that is Methods of Finding the Minimum Kilometerage in Cargo Transportation in the Space. Okay, and the major advantages were made in the field during World War II by Leonid Kantovich. So, as I told you, we discussed in the introduction part also, OR is maximum used in the World War II. That's why they have been implementing in every field and using in the every field also. Even in our daily life also, we are using so many times without knowing about it. Because we know the techniques, we know somewhat, we learn from our parents. So the same techniques we are applying in our daily life also. Sometimes stated as Monge Conrich transportation also. But the linear programming formulation is known as the Hitchcock-Koopman's transportation problem. So it is also one of the linear programming problem, we can say. So the basic transportation problem was developed in 1941 by F.I. Hitchcock. We can't spell it properly because all these are not Indian names. So, however, it could be solved for optimally as an answer to complex business problem only in 1951 when George B. Danzig applied the concept of linear programming in solving the transportation models. So, even for the transportation problems, Danzig gave a concept of LPB. So, transportation problems are primarily concerned with the optimal way, that is best possible way in which a product produced at a different factories or a plants can be called as supply origins, can be transported to a number of warehouses called as demand destinations. So what we need to do from supply origins to the demand destinations, we need to transport the goods which were produced. That is actually the transportation problem, we can say. So it is a special kind of linear programming problem in which goods are transported from a set of sources to a set of destination subject to the supply and demand of the source and the destination respectively, such that the total cost of transportation is minimized. Ultimate aim is the same, minimizing the cost or maximizing the profit. So if you minimize the cost, automatically the profit also maximum you'll be getting. So here it is the expenditure related companies, so that they'll be thinking about the cost only. They'll be trying to reduce the costs. So objective in the transportation problem is to fully satisfy the destination requirements within the operating production capacity constraints at the minimum possible cost. That is the object of transportation problem, as to fully satisfy the destination requirements with the operating production capacity constraints at the minimum possible cost. So what it can be said, whenever there is a physical movement of goods from the point of manufacture to the final consumers through a variety of channels of distribution, because The wholesaler will be buying from the distributor, right? Distributor is buying from the manufacturer. So goods are transporting from the manufacturer to the distributor, from distributor to the wholesaler, wholesaler to the retailer, retailer to the ultimate consumer. Means what? It is reaching from one stage to the another stage. So one place to another place it is going means what? Everywhere they require the transportation. So there is a need to minimize the cost of transportation so as to increase the profit on sales. So transportation problem arises in all such cases whenever we are transporting the goods from one place to another place. That is what the transportation problems we can say. So wherever there is a physical movement of goods are going on, at the time we require to solve our problem of transportation and reduce the cost of transportation. That is the aim of transportation problem also. What is the aim? So to find out the optimum transportation schedule, keeping in mind the cost of transportation to be minimized. Optimum, I told you, the best transportation schedule. To find out the best transportation, they'll be keeping in the mind the cost of transportation must be minimum. The origin of a transportation problem is the location from which shipments are dispatched. There only the transportation problem starts. The destination of a transportation problem is the location to which shipments are transported. And the unit transportation cost is the cost of transporting one unit of consignment from an origin to a destination. So these are the aims. Optimum transportation to minimize the cost, finding out the origin of transportation to locate the shipment charge, destination to find out where to transport and how much is the unit cost. These they'll be keeping in the mind to minimize the cost of transportation. Right. So it aims at providing assistance to the top management in ascertaining how many units of particular product should be transported from each supply origin to each demand destination to that the total, so that the total prevailing demand for the company's product is satisfied, while at the same time the total transportation costs are minimized. Are you getting my point? Is that clear? So all the things whatever we discussed about the theoretical for reading purpose to give the answers if they ask you about the theory. Aim or objective is same thing we can say. Determination of a transportation plan of a single commodity from number of sources to a number of destinations such that the total cost of transportation is minimized. And the application where it is applied most of the time, it is used to compute transportation routes in such a way as to minimize the transportation cost for finding out locations of warehouses. It is used to find out location of transportation corporations depots where insignificant total cost difference may not matter. Minimum shipping costs from factories to warehouses. At the time, we require this information compulsorily from warehouses to retail outlet. Determine lowest cost location of for new factory, warehouse, office, or other outlet facility. So to determine that also, they require this transportation problem. Then find minimum cost production schedule that satisfies the firm's demand and production limits. Transportation problem is one of the most frequently encountered application in real life situations and is a special type of linear programming problem. And the transportation problem indicates the amount of consignment to be transported from various origins to different destinations so that the total transportation cost is minimized without violating the availability constraints and the requirement constraints. So with the limited resources only, they want to transport the goods and minimize the cost of transportation. The main thing is you need to understand the problems, what type of problems you will be getting is here. There will be a two types of problems. One is balanced transportation where the total supply equals to the total demand. Unbalanced transportation problems will be there where the total supply is not equals to total demand. That is called as unbalanced. And here to find out the best solution, there are the phases to be followed. Phase of solution of transportation problem. Phase 1 obtains the initial basic feasible solution. What is this? IBFS, shortly we can call it as. In sometimes they may ask you in the theory as in the short form also. What is IBFS? IBFS is nothing but the first phase of solving the transportation problem, that is to obtain the initial basic feasible solution. Feasible solution we discussed in the graphical solution also. Feasible means what? Getting the profit by satisfying all the conditions, reaching the object by satisfying all the constraints, all the conditions, all the restrictions. Whereas phase 2 obtains the optimal basic solution, that is the best solution we are finding out among all the feasible solutions. So the best solution, whenever we are getting it, that is an ultimate solution, we can say, even for the transportation also. So there will be two things. One is IBFS, initial basic feasible solution, and another one is optimal solution. In the two phases we need to go to solve any transportation problem. So before solving it, first we need to check whether it is a balanced transportation or unbalanced transportation problem. So to find out IBFS, initial basic feasible solution, there are three methods. One is northwest corner rule method. Two is least cost method. Three is VAM method, that is Vogel's approximation method. There are the three methods to find out the basic feasible solution. Whether the solution is there or not, that feasible solution we can find out by means of these three methods. Optimal solution, to find out the optimal solution, MODI method, that is modified distribution method, and two is stepping stone method. So stepping stone or MODI method. So MODI method includes the stepping stone, so those two are almost similar. So anyhow, there is small change. So three methods are there to IBFS. Two methods are there to find out the optimal solution. So up to this, theoretically, if you know, to learn, or if you read once, then easy to understand. So to solve any transportation problem as a numerically, first we should find out whether it is balanced transportation or unbalanced. If that unbalanced transportation is given, that is to be converted into balanced transportation, then we can go with these two phases. Phase 1, finding out the basic feasible solution. 2 is finding out the optimal solution. Is that clear?
Yes, sir.
Yes, sir.
So up to this, theoretically enough. Further we'll discuss as a numerical part in the next session. Any doubt regarding any of the things you can raise your doubts.
Sir, you told in the initial basic feasible solution there are only 3 methods, right?
Right.
But in the book they have given 5 methods. So the row
They
minimum,
may,
row minimum and column
right.
minimum.
Right. Least cost method, I told you, no? In that, they can go with the row minima method or column minima method separately. Combinedly, it is called as a least cost method.
Okay, sir.
So instead of naming them separately, I'll call it as only least cost method.
Means in case if they ask for the row minimum method
No.
from the same what we have asked, we can solve it, sir.
Yeah, I can explain that one. I'll tell you what to do. Row
Okay.
minima, only row wise minimum value to be considered. Column minima, column wise only minimum value
Okay.
need to be considered.
Okay, sir.
Most of the time, they won't be asking row minima, column minima. They'll be asking LCM, least cost method.
Okay, sir.
Any further doubts?
No, sir.
Any other doubts? Okay. Okay, done for the day. We'll discuss further in the next class. Good day. Right, sir? Radhakrishna, sir? Any?
Thanks.
I think he's busy. Okay. Good day.